Okay, Foundations of Math 24.3. Here's number 1 from your assignment. I've got you doing 1 to 5, 9 to 15 here today. So, number 1. Okay, so given each set of measurements for a triangle ABC, determine if there are 0, 1, or 2 possibilities. Draw the triangles to support your answer. Okay, so let's do number A. Letter A, whatever you want to call it. Okay, so angle A is 75. Now I'm going to, again, I always do this, just give a rough sketch, 75, okay? The adjacent one as side is 12 here, okay? And the opposite side is 4. Okay, so already, if you draw this roughly to scale, because this angle, guys, is so big, and this side is so long, you see, this is roughly to scale, so I can tell already there's probably going to be no triangles formed. Do you guys see that? No, because it's frozen? The screen's frozen? Okay, so there you go. So if you sketch this and try to make this roughly to scale, you're going to see that, hey, 4 is not going to be long enough because that's like a third of this length. So it's not going to work. That's not enough, though. What you have to do is you have to say, okay, how does A compare to B sine A? Okay? How does it compare to side A? So B sine A is 12 times sine of 75. And how does that compare to our given side of 4? So let's do that. Because remember that B sine A is going to represent the minimum length that we would need to have a triangle form. So 12 times sine of 75. That's 11.59, guys. Okay, this is 11.59. So what this is saying is that, look at this. In order to form a right triangle, the minimum side length for this opposite side would have to be 11.59, because that's what would make a right triangle. You see that? That's what this is saying. And so if we compare that to 4, well, this is greater than 4. 4 is less than the minimum required. So guess what? There are no triangles formed. Yeah? Starting to click?
Yeah.
Okay, let's do B. Okay, so angle A is 50 degrees, so I'm going to try and make about a 50 degree there. And the opposite side is 10, the adjacent side is 6, so this is 6. Oh, and look at this, the opposite side is 10. That's way bigger than 6. So guess what? I know automatically, because A is greater than B, there's one triangle formed. You don't even have to do any calculations. You don't have to do B sine A. You don't. Because you know that this minimum, obviously, because 10 is bigger than 6, this is going to be way bigger than the minimum, right? Because it's bigger than even this side. So A is greater than B, one triangle formed. You're done. Okay. Let's do C. Let's check C. And you guys may be looking at this and saying, oh, I actually get this now. So C, angle A, 115. Oh, we got an obtuse going here. Obtuse. Okay. Now, we didn't really talk about obtuse much, but just use logic here. Okay? If the angle is 115, okay, and this is 9, all right, you're not gonna form a triangle on this side. Why? Because this angle is not gonna be 115 anymore, right? So you have to form a triangle over here somewhere. It has to be over here, which means that this side length right here, A, must be greater than 9. Greater than 9, right? Because it's got to be longer than this side to stretch and touch over here somewhere. So let's check that out. Is A greater than 9? No, it's not. If I were to draw that to scale, guess what? 3 would be like literally hanging in the wind right here, a third of 9. See? So there's no way that that's going to touch this side. You see? Okay. So, yeah. This wasn't on the chart. But let's check. Okay. Let's check, what does B sine of 115, what is 9 times 1? This is probably not going to help us, but let's just check. What is that? 9 times sine of 115. Okay, that's going to give us 8.15. Now, no, we didn't, I don't think we talked about this. Maybe we talked about this yesterday, but with 115, this 8.1 whatever is going to be this minimum distance down here to drop to touch. Okay, but that's outside the triangle, so that doesn't count. The b sine a for an obtuse triangle doesn't count. Okay? Let's just jot that down. We didn't put that in our chart, but that's almost something that should go in our chart. So let's just, hang on, let's write that down. All right, so a little note, wherever you put this in your notes or here, just make a little star beside it. For an obtuse angle that's given, the opposite side must be greater than this adjacent side given, or else there's no triangle formed. Okay? So that could go in your chart from your notes there. We didn't add that, but you could add that now. All right, D, let's do one more. Let's get rid of B over here, and this stuff. So D, angle A is 62. Okay, so let's see, this is about 62 here. B is 3, and A is 2.8. Okay, I don't know. Let's see, 2.8. I don't know if that's going to be enough. Let's just check. Let's check. So B sine A is going to be 3 times sine 62. And what does that equal? 2.65? Okay, yeah, you agree? So 2.65. So this is the minimum that has to be achieved here. 2.65 touches right here at a right angle. So do we have more than 2.65? Yes. Yeah, you bet. So guess what? That side would technically be longer than the minimum necessary, but it's also shorter than this. So the two triangles that we're going to have, 62, we're going to have this 2.8 over here, and 3, and then we're going to have a little obtuse triangle right here, where this is 2.8, and that's 62. Okay? Any questions on that? Is that making sense? Okay, B sine A is very important. Compare that with the opposite that is given. Okay. All right, that's number 1. Are there more questions in number 1, or does it just go to D for you guys? Okay. All right, number 2 is right here. So guys, go ahead and get on number 2. Decide whether each description of a triangle involves an SSA situation. So remember, are we given an angle, its opposite side, and then an adjacent side? Because if the angle is included, that's not an SSA, right? The angle can be here, or it can be over here. So for number 2, we have angle B, we have the opposite side, angle B, and then we have an adjacent side. So yes. That's good. Angle D, side E, and side F. So if this is angle D, this would be point E, point F, let's say. So we're given angle D, we're also given side E, that's this one, and we're given side F. Does that look like SSA? Yeah. No. That looks like cosine. That's SAS. That's different. Yeah. This is SAS, so this is not SSA. So if you have two sides in the contained angle, then you can use cosine law, and you can use sine law. There's only one triangle that can be formed. It's the SSA. And if you switch it around, right, it could be this, SSA. Could be this too. That's SSA too, right? Or, again, if this is A, this is S, this is S. That's SSA, okay? So it doesn't matter how you rotate the triangle. They have to be in this arrangement to be SSA. All right, so A is yes, B is no. The rest is up to you. Go. What kind of rhyme? All right, there's your Simon. Give her. Good. Right, know what they're doing? Awesome.
Now this is where the math comes. Calculate the height. Well, you just calculate the height. I don't.
Check over here.
Determine. It's fine. No, you have to determine.
I do have one here.
Wait, I mean, for we know that there's no